Hi, everybody. Welcome to the monthly office hour. We're going to be starting in a couple of minutes. In the meantime, if you haven't already, please join the community Slack channel as we will be using that for the Q&A and discussions. The Slack channel is alluxio.io/Slack. However, if you're having any trouble joining Slack, you can still message me your questions instead. We just find Slack to be a little bit more interactive so that you can also have discussions with your fellow folks who are also joining the office hour. Hi, everybody. Welcome to today's office hour, hands-on with Alluxio Structured Data Management. My name is Amelia, and I will be your moderator. Before I introduce you to our speaker, I have a few housekeeping items. All participants are automatically on mute throughout the session. We will be using Slack to communicate, so please take a moment to join us on the community Slack channel, which is copied in the chat box. It's Alluxio, alluxio.io/Slack. However, if you're having trouble joining Slack, feel free to message me your questions instead, and I will share it with the group. Today's session will be split into a quick presentation followed by a really cool demo. We will have a Q&A session at the end of each section so we can answer all of your questions. A reminder again, to ask a question, join the community Slack channel posted into the chat box, or you can message me your questions instead. Lastly, today's session is being recorded and will be available for on-demand playback. We will email you the link to the presentations as well. That's it for housekeeping, so let's meet our speaker. I'm very pleased to welcome Jean Pang. Jean is the PMC maintainer of the Alluxio open source project and head architect and founding member of Alluxio. He graduated with a PhD from the AMP lab at UC Berkeley, working on distributed database systems. Prior to starting at Berkeley, he worked at Google and has an MS from Stanford University and a BS from Cornell. Without further ado, please meet Jean.
Thank you. Thank you for attending this office hour on some of the cool new innovations that we have in Alluxio for structured data management. So this is a brief outline of what I'll be talking about today. First, I'll talk and motivate why we are looking at improvements to structured data management in Alluxio. And then I'll give a high-level overview of the Alluxio Structured Data Management components. Then I will discuss some of the components that are available in the developer preview in Alluxio 2.1, which has been released in a few months ago. And then I'll show a quick demo on using the various features and components in the Alluxio Structured Data Management component. So first I'll talk about the motivation for this work. So with Alluxio, there are many different types of users today, and they get a lot of benefits using the current state of what Alluxio is. Typically, there are various different storage systems that applications and users are trying to access, such as S3 or like the Google Cloud or HDFS. And there are also many different types of applications that can access that data through Alluxio. And with Alluxio provides a unified interface to the data, so it doesn't matter where the data is stored. The applications can access a single interface to access their data. Also, Alluxio provides this unified namespace that unifies the various namespaces of different storage systems to the application. So it simplifies how applications access data. And also, Alluxio provides a lot of caching and locality benefits for the data, so that the data is stored and cached closer to the application to provide acceleration. So something that we've noticed through all these use cases of Alluxio is that a lot of users use SQL engines and for their computation framework on top of Alluxio. And so this is, we decided to take a closer look at SQL engines and SQL workloads on Alluxio. So what we noticed was that there are interesting characteristics between how storage systems store data and how SQL frameworks and SQL engines process data. Well, first of all, storage systems, they primarily deal with files and objects and directories and hierarchy of directories, and it also provides access to raw bytes of the files. Ultimately, storage systems store their data in a storage optimized way. On the other hand, SQL frameworks, they primarily process data in a more higher level, such as tables, rows, schemas, columns, and SQL engines don't necessarily access directly files and objects, but rather a more higher structured data concepts such as tables, rows, and columns. And also, SQL frameworks tend to desire their data in a more compute-optimized way. And so this really shows that there's some sort of a impedance mismatch between what storage systems provide and store versus how SQL engines and frameworks want to consume and process that data. And this mismatch and this gap actually really highlights the opportunity to further expand the benefits that Alluxio can provide. So coming to the Alluxio system, we see that with this gap and difference between storage systems and SQL frameworks, we see that Alluxio is a great bridge between these two pieces of the ecosystem. And already, Alluxio is already addressing this gap by providing the caching benefits as well as the unified interface and namespace benefits that Alluxio has today before 2.1 version. But in addition to that, as we look into more structured data and SQL engines, there are further benefits that we see possible. One such optimization is schema-aware optimizations. Currently, Alluxio is not able to utilize the information that is provided by the schema. And so by using the schema for the SQL engines, Alluxio will be able to provide additional and more optimized benefits. Also, Alluxio can provide compute-optimized formats by providing SQL engines and SQL frameworks a compute-optimized way that is not necessarily the same representation as what's stored in the storage-optimized way. And that ultimately comes to a really powerful concept, and that is physical data independence, which really separates how the data is stored versus how the data is consumed. And this, with Alluxio, we think that Alluxio is a great place to be able to provide these types of benefits. So next I'll talk a little bit about the components involved in this Alluxio Structured Data Management. So at a very high level, there are two main high-level points of philosophy that Alluxio, the structured data management piece has. Number one is being able to provide structured data APIs. And this really is focusing on how frameworks interact with data. So SQL engines interact with data such as tables and rows and columns, and these are the types of APIs that this will focus on. In addition to that, another point is to be able to cache logical data access, meaning instead of being able to focus on caching what SQL frameworks want and how SQL frameworks want to process their data. So here is a visual representation of the different components of Alluxio Structured Data Management. On the left, we have the storage systems, and on the right, we have the SQL engine. And in the middle, we have Alluxio's Structured Data Management. One component of this is the transformation service, and this is an important piece to be able to provide this physical data independence, to be able to transform data into a more compute-optimized way. Next, we have structured data and metadata management, where Alluxio manages metadata about the structured data, as well as the actual payload of the data, whether it's cached data or whether it's transformed data. And lastly, there is the logical data access layer, which is essentially the client of the structured data management portion of Alluxio. And this is the client that is used by the SQL engines in order to access the various components and various pieces of data from Alluxio Structured Data Management. And so next I'll describe some of the components and go into more details on these components and describe some of the features that are available in the developer preview, which is in Alluxio 2.1. So the target environment for the developer preview is this type of Presto environment, where the Presto is using the Hive connector and accessing some storage system, as well as accessing the Hive metastore. So this is the target use case that the developer preview is addressing. So the first change is that Alluxio in the developer preview is providing Alluxio connector, and this connector is used to communicate with the various components of Alluxio. Next, there's the Alluxio caching service, which is what Alluxio already does today before this preview, and this is able to cache the data closer to the Presto workers and accelerate that access. We also have the Alluxio catalog service, which is mainly responsible for managing the metadata of the structured data of tables and rows and schemas that can be pulled in from the Hive metastore. And also there's the Alluxio transformation service, and this is primarily used for transforming the data that is in storage optimized formats and transforming it into a more compute optimized format, and which can then be served to the Presto workers. So here's a brief overview of the Alluxio catalog service. The main functionality is to manage the metadata for these tables and rows and for the structured data. And one of the main ways it does this is being able to abstract out different types of database catalogs, something that we call under database. And this is and so in the developer preview we have an implementation of the Hive metastore, the Hive under database, which then allows the Alluxio catalog service to access other Hive metastores and pull in data such as the schemas and tables and database information. And this actually provides a lot of benefits, such as being able to enable schema-aware optimizations. By understanding what these pieces of data and tables, how they're laid out and how they're stored, this gives us a lot more information to make optimizations on those tables. In addition to that, it provides really simple deployment by being able to simply attach a Hive metastore to the catalog service. It provides essentially a unified catalog, as well as being able, not having to modify any existing Hive deployment. Next, we have the Alluxio Presto connector. This is a new connector in Presto, which provides a tighter integration with Presto. It's a new plugin that's based on the existing Presto Hive connector, and it is in our distribution in Tarball. And as as we're speaking, we are in the process of trying to merge the connector back into the Alluxio, the Presto code base, so that it's available in the sources available. And lastly, we have the Alluxio transformation service, which ultimately is the functionality is to transform data to be compute optimized, which is independent from the storage optimized data. And this is actually what is really enabling the physical data independence for the application. So there's, in the developer preview, there are two types of transformations available. One is coalesce, which essentially takes many files and coalesces them into fewer files. And so that can be beneficial, since if typically in like Hive workloads, if there are too many files, then that can slow down the queries. Also, there is a format conversion transformation, and specifically it's the CSV to Parquet conversion. And so since CSV is typically a slower, less optimized, since CSV is a less optimized layout of the data, if we transform it into Parquet, it's a more compute optimized layout. So next, I will show a quick demo on the various on this new sets of features. Here is the demo setup. We have two isolated clusters, and one cluster has Presto with the Hive metastore on S3 data, and that does not have any Alluxio on that cluster. And the other cluster has a Presto with Alluxio with the Hive metastore and S3 data. So basically, one cluster has Alluxio, one cluster doesn't. And the data we're using is just a sample data set. That's the TPCDS data set. And just to highlight some of the transformations, some of these tables have thousands of CSV files, which is not a very compute optimized layout. So next, I will switch over to the demo portion. So the window on the left here is the cluster that has Presto and Alluxio, and the window on the right is the cluster without Alluxio, and they all have Presto and Hive. So the first thing we're going to do is we are going to attach a Hive. We are going to attach a Hive database, a Hive metastore to Alluxio. And so that's this command here. We have the attach db command, which essentially just takes a location of a existing Hive metastore and imports it and attaches it to the Alluxio catalog service. And after doing that, we can see that the Alluxio catalog service can show the tables that were imported, and that is this command, where it's showing the various tables that have been imported, and these are the tables that are part of the TPCDS framework. So next, we will show how the Presto Alluxio connector is configured, and here is how it's configured. It's very simple. We just have to provide the connector name to be Hive Alluxio, and then we have to essentially point to the Alluxio master, and that's all that needs to be done. And so then we will start Presto using that Alluxio catalog. So first I'll show the tables that are in this catalog, and these are the same tables that were in the Alluxio catalog service. And I'll also do a very simple query. Just to see that after all we have to do is attach to be able to read data from Presto through the Alluxio catalog service. So with that, what that query just did was Presto contacted the Alluxio catalog service to see what the locations were. The catalog service returned Alluxio locations, and then Presto was able to read from there. So as I mentioned before, these tables are not very optimized since there are thousands of CSV files, and typically having too many files is not very optimized. So what we're going to do now is we're going to run a transformation for a particular table, which is the store sales table. So I just ran a command to transform the store sales table in Alluxio. And what that's going to do is eventually, what that's going to do is that's going to run a job that transforms that table and be able to coalesce and convert the format to Parquet. And then later, it'll store the data in this path here. So right now, it doesn't exist because it hasn't finished the transformation yet, but soon this location will have the data that has been transformed. So next, we're going to go to the other cluster on the right, which is the Presto cluster that does not have Alluxio on it. So I just started Presto running on Hive directly, and here I'll just show tables, and it will show the tables available in the Hive metastore, and these are the same TPCDS tables. And then next, I will run a sample query that uses the store sales table. So query 63 is a query that that uses the store sales table, and this will take a few seconds. And so in this scenario, Presto is accessing Hive metastore directly, which is then going to access S3 directly in order to run and process that query. So this query just finished, and it took about 19 seconds. And so that's what the query looks like without Alluxio and without even accessing Alluxio. Now going back to the Alluxio cluster, let's see if the transformation is done. So yeah, the transformation is done. We have a bunch of data now here. We have about a gig or 1.5 gigs of data that is transformed. And so then let's see how we can run the query on the Alluxio cluster. So we'll take the same query 63, and run it in the Alluxio cluster. And so now what this will do is the catalog service will actually return. Okay, so that finished a little bit faster than the Presto query. So this took about 8 seconds to run. And that was because this data is now more optimized. It's in the Parquet format, and it's also fewer files than 10,000 or however many files there were. And that's because the Alluxio transformation service was able to transform it into a more compute optimized way. However, as you noticed before, its first start off, nothing was cached in Alluxio. So what this query ran was running the query. It was pulling straight from S3 again, but it was just the optimized version of that data. But if we now, after we ran that query once, if we look at the status of the data now it's 100% in Alluxio. So Alluxio has cached 100% of that data, of that table, of the store sales table. And so now, not only is it transformed, but it's also cached in Alluxio. So if we run the query one more time, after it's been cached, it'll complete faster, even faster than before, which is about 4 seconds instead of the 7 or 8 seconds it was before. So this is you can sort of see how initially in the Presto cluster without Alluxio, it took about 19, 20 seconds. We then, after we transformed it, got it down to about 7 or 8 seconds. And then after it was transformed and cached, it's down to like 3 or 4 seconds. So just to summarize the demo, I first attached an existing Hive database into the Alluxio catalog, and that was able to access the Alluxio catalog was then able to access that information. The Alluxio catalog then serves all the table metadata and schema information for Presto, so that Presto can get all that information directly from the Alluxio catalog. And lastly, I showed that I transformed the store sales table with the Alluxio transformation service by coalescing and converting the CSV format to Parquet. And after doing all that, first without Alluxio, the Presto ran about 19, 20 seconds with that query directly on S3 and Hive. Next, after we transformed the data with Alluxio, it was about 7 seconds when it was coalesced and transformed into Parquet format. And then lastly, after we had the transformations and the Alluxio caching service, the query goes down to about 3 or 4 seconds. So here you can see how all the different components of Alluxio really interact to be able to provide much faster access to that data. So I'll finally conclude. I first want to talk about some of the future work that is in planning. And so obviously one of the most important things is just getting community feedback on the features and on the components in general. And collaboration is very important. So it's really it'd be great to just see more usage of these features as well as more feedback. And then some of the future projects that we have in progress is being able to provide new UDB implementations, such as accessing Glue and other conversion formats, such as using JSON. We also plan to, we're also working on the DDL and DML work queries, such as like create tables and inserts. And then finally, we are looking at additional client APIs, like more advanced APIs for structured data. And so finally, the developer preview is available today in Alluxio 2.1. And so you can always try it out, and we have documentation for that. And also, feedback is like very, very important and something that we really, we're really thankful for. And so any type of feature requests or issues can be directly added to the GitHub for Alluxio. So that is it. Thank you. Thank you very much.
Thank you, Gene. So we have quite a few questions here. And a reminder for folks, if you're having trouble asking questions on Slack, feel free to just message me through the GoToWebinar control panel under the tab Questions. So our first question here is the transformation service able to continually transform and add to the Alluxio data? As in, if I have a CSV files added in batch every day at midnight?
Yes, so that's a great question. So today there's no automatic continual transformations, but that is something that we are looking into by being able to essentially continually sync the information of new data or new partitions, and then be able to trigger new transformations from that. So that is something that is something that we're going to work on.
Great. Next here we have, after the transformation, the data is not cached?
Yeah, so so that is true, right? So that is I think that is a configuration for it, but essentially the idea was that some of these tables could be large, and so transformations could take a long time, and not the entire table may not be particularly important for lots of the queries. So first, it's transformed in an uncached way, and then after the next access or the first access of that cache of the transformed data will essentially cache on demand, and then future accesses can access that cached data.
Great. Here we have two questions. How long was the transformation itself? And say the data was in Parquet to begin with, what is the delta with Presto?
I see. So if the data is already in Parquet, I'm not sure what. The demo didn't show that obviously, but I'm not exactly sure what the exact numbers are. But in this example, we showed sort of benefits of two different types of transformations. One that was coalescing many files into fewer files, and then the other one was the CSV to Parquet. So if it was already in Parquet, it would only get advantage from having too many files down to fewer files. I don't know, so that also provides benefits as well, but I don't know the exact breakdown from the demo.
Great.
And the other question was how long did it take or something?
How long was the transformation?
Yeah, so this is a small, this was like a small example, so it probably took like, less than like 30 seconds or so. But it really depends on the size of the data itself, because for these transformations, it does have to transform the table.
Great. So does Presto have to access both the Alluxio catalog service and the Hive meta store?
I see. Yes. So the question. So if you use the Alluxio catalog service and if you use the Alluxio connector for Presto, then Presto will only access the Alluxio catalog service, and the catalog service will access the Hive meta store if it needs to get information from the Hive meta store. So in the perspective of Presto will, if it's using the Alluxio connector, it will only access the Alluxio catalog service.
Okay. And then does the catalog service support writing into existing tables or existing partitions?
So the answer to that is no, not yet. Right now, the only read-only workloads are supported, but we are actively looking into trying to support write workloads as well.
If the transformation does not fit in memory, does it go back in storage?
Oh yeah, this is a similar related question to the previous question. So the transformations are actually aren't written in memory first. It's actually written down to the storage first, so that it doesn't pollute the cache. And then as users or queries read the transformed data, it will cache on demand the portions of that table of that transformed data.
Next, here we have, if the Hive data tables are updated, can Alluxio pick up the change?
That's a great question. So right now in the developer preview, it will pick up new partitions, but not updated old. So if you add partitions, it will pick up new partitions. However, if you change or update an existing partition, it will not pick that up. However, that is currently being worked on, so it will be supported in the near future.
Having ACID support planned on structured data, does it mean at some point a append file will be supported on Alluxio blocks?
So, yeah, that's a great question. So, yeah, we do plan to support some of those update types of semantics in the structured data portion. That doesn't necessarily mean we will have updatable blocks and appendable blocks. There are different ways that you can support updates and updates and deletes and things like that in the structured data land. So that yeah, it may not, those two concepts are not like required for each other.
So Presto works with different databases. What compute optimized structures have you identified as common for all the different databases?
I see. So common for all the different databases. So the main the primary use cases typically is with Hive tables, which are essentially backed by files or objects. So in those scenarios, we've um, we've typically uh, we've typically seen that more columnar types of formats are more optimized, such as Parquet and ORC. So those are typically the formats that are most recommended in Presto queries. Now, in other databases that Presto can access, some of those aren't even like file-based, and so in those scenarios, then it really depends on how Alluxio might be able to access those databases. And so today, the only UDB that we have implemented first is the Hive UDB. But as we can look into additional database types as we add more UDB implementations in the future.
In addition to Hive tables, can I import tables from databases like MySQL?
Yeah, that's a great question. So that's not there in the developer preview right now, but that might be coming in the future where we would need to implement a UDB implementation for MySQL and then be able to essentially read or transform the data from that UDB into the Alluxio structured data management system. So that's not there today, but with the UDB concept as well as the catalog service, we can, it's like a pluggable, the UDB is pluggable, so you can easily create new implementations of the UDB to be able to access different types of databases.
Here we have another question. When I was using persistence and caching, it seems to be a very simple decision in terms of you just need to decide a few places that you need to cache, or otherwise you should not take up too much memory. Do you think these can be automated inside Presto, or is there more to do with the logic and more complicated?
That's an interesting question. So what I would say is it doesn't. So with the Alluxio Structured Data Management, it doesn't change the semantics too much about the caching and the persistence. However, what it does do is it enables additional metadata, like sort of table-related and structured metadata. And what that can do is, I think I think using that structured data metadata, we can actually cache things more intelligently and be able to maybe even persist things more intelligently. Now that we have access to schema information, we have access to table information. And so, and even with, and also in addition to that, since we also do have the connector, we may be able to provide additional information from Presto to Alluxio as well as from Alluxio back to Presto. So by having more like tighter integration with Presto, I think we might be able to share more metadata more effectively to make more automated and intelligent decisions.
There are a lot of great questions here relating to Presto. So I just wanted to mention before we continue with the questions that we are holding the first Presto and Alluxio workshop series in the Bay Area. It's a standalone 3-hour Presto and Alluxio hands-on training. I've pasted the link into the chat box in case anyone is interested in learning more about that. And we'll also be sending a discount code to everyone who attended the office hour today. So continuing with the questions, the next here we have, what challenges were there in creating the Presto connector?
I see. So for the Presto connector, at least the initial version of the Alluxio connector, it's actually based on the existing connector. So there weren't many challenges there. But as I mentioned before, if we want to add more features or more, custom or like more automation or intelligence there, then we would have to augment it far greater than we have today. But for right now, it's very simple and you know heavily leverages the existing connector.
Next question here. Is there an advantage in directly dealing with the Hive metadata with Alluxio so there's a direct path to the S3 store? For example, is the meta store in the critical path?
Is there an advantage? I'm not exactly sure what this means. Is there a direct path to the S3 store?
In that case, we can move to the next question, and if the person who asked this question could please clarify. So next here we have, if I'm using ORC files, can I use Alluxio Structured Data Service?
Yes. So Alluxio can provide access. So Alluxio Catalog Service can enable Presto to access anything that the Hive metastore itself is exposing. However, for transformations only, transformations can only either read CSV or Parquet files and then convert to Parquet. And so if you don't use transformations, then you can read any of the files formats that already exist in the Hive metastore.
Great. Next here we have, is there a different representation of the transformed versus the cached representation?
Oh, great question. So the two representations are the same. So whatever the result of the transformation is, that is what's going to be cached in Alluxio. Now, what it is different is the transformed representation versus the stored representation. So in our example, we had our table was in S3 and it was in many CSV files. And so that was the representation of that table. And so the transformed version of that table was fewer Parquet files. And so those two representations are different from each other. And so then when the transformed data is cached, we are caching portions of the fewer Parquet files and not the many CSV files.
Great, that's all we've got for now. We still have some time here, so we're going to hang on if anyone else has any other questions, or if you wanted to clarify. Oh, here we are. Here's our next question. How much of the Hive metastore info is cached?
The Hive, so the main things that are cached in the Alluxio Catalog service is essentially the schema information and the partition information, and the database information. So I think that's probably most of the data that Hive has. I'm not aware of more metadata that the Hive metastore stores.
Okay, great. So as I mentioned earlier, we are holding Alluxio and Presto training sessions in the Bay Area. If you're interested, check out the link that I posted into the chat box, as well as if you have interest in other trainings or topics for future office hours and meetups, feel free to post that to us as well. And these types of discussions are always ongoing on our community Slack channel, which you can join at alluxio.io/Slack. We will be hanging on for a couple more minutes, but thank you everybody for joining us today, and thanks Gene for a great presentation.
Yeah, thank you for everyone joining and for all these wonderful questions, and I look forward to seeing more questions and users on the Slack so we can interact there. Thanks.